Okay, we want to try to find some derivatives, first and second derivative of this function here. So if you haven't done the first derivative of this one yet, please stop it, stop the video, and figure it out now. Come back when you're done. Press pause now. Okay, the best thing we can do with this is to use some properties of exponents, and or actually properties of logarithms first. The square root can be written as the 1/2 power. And we could take the absolute value of the numerator and denominator separately here. Let's see here. What else can we do? We can since this is a logarithm of something to the 1/2 power. Property of logarithm says we can put the 1/2 out front, and then the log of this quotient is the difference in the logarithm. So it's 1/2 the log of the absolute value of 4x minus 7 minus the log of the absolute value of x cubed. So think of that as the way to write f of x, and it's a little bit easier to find the derivative now, because we can start by using the constant multiple rule to bring the constant out front, and then we can use the sum rule to take the derivative of the sum as the sum of the derivatives. So the derivative of this sum is the derivative of this part plus the derivative of this part. Well, the derivative here, well, that's what I've written here. And I've also used the constant multiple rule again to bring that -3 out front of the derivative sign here. Derivative of ln of absolute value of x is 1 over x. Derivative of ln of absolute value of u is 1 over u times the derivative of the u. Derivative of 4x minus 7 is 4. So this is 4 over 4x minus 7 minus 3 over x. And we still got our 1/2 out front. That's the answer. But let's go ahead and clean it up by getting a common denominator, put it in one fraction. So our common denominator is going to be x times 4x minus 7. So take the first fraction and multiply numerator and denominator by x. Take the second fraction multiplied by 4x minus 7 in the top and bottom. We now have a common denominator, so we can just simply add the numerators, keep the same denominator. Distribute here to get -12x plus 21. Combine like terms to get -8x plus 21. Factored out the -1, and I have 8x minus 21 over 2x times 4x minus 7 with a negative out front. And there is the derivative. We can check that. As usual, let y1 be the original function. I put it in like it was originally written. y2 is the numerical derivative of y1 with respect to x, evaluated at x, and y3 is our final answer. And the check is that the tables for y2 and y3 match. So we check that. And so we got this nice little polynomial function, or this little rational function. Notice that this function is undefined when x is 0 and also when x is 7/4. And that's exactly when the only places when the original function is undefined. If x is 0, we're dividing by 0 here, so that certainly makes the whole thing undefined. If x is 7/4, we got 0 divided by non-zero is 0. Absolute value that's 0. Square root of 0 is 0. But logarithm of 0 is undefined. Anything else we put in, we're going to get something here when we do the fraction. Absolute value will make it positive, so the square root will be defined and be a positive, and the logarithm of that will be defined. So the only places it's undefined are when x is 0 and when x is 7/4. And I believe both of those will give us vertical asymptotes on our original function. If you look at the graph here, the blue graph, you see a vertical asymptote here at x equals 0, and also here at 7/4. Okay, so this is we don't have to put any extra restrictions. This is defined exactly where it should be, and it's undefined exactly where it should be. Now to go on and take another derivative, we're going to use quotient rule here, or perhaps we might rewrite it with negative exponents. So I did the quotient rule here. Put the negative out front, constant multiple rule, and take the bottom times the derivative. Actually, I distributed in the bottom. We may factor it back out again later, but right now I distributed. I wrote it like this. So we got the negative out front, and then it's the bottom times derivative of the top minus the top times derivative of the bottom over the bottom square. Derivative of the bottom here is 8. The derivative of the top is 16x minus 14. Right there and right there. Distribute here. Still got the minus out front. 64x squared minus 112x minus Okay, now here I did FOIL and then distributed the negatives, so that's sort of two steps going on there. Get here, combined like terms were here. Let you kind of chase through the details there. Pause if you need to stop and chase through that. Combine like terms to get to here. I actually also ended up with a negative leading coefficient, so I distributed this negative back out through there. And that's how I came up with this version. And then, so that's where the negative went in the front. And then I factored the 2 out of the numerator and left it like, well, canceled the 2 with the 4 here, and left it like this for the final answer. So again, you can see the second derivative is also undefined when x is 0 or x is 7/4. Okay, and notice that those in the first derivative were first power here, and notice they increased to second power in the its derivative, the second derivative. And this numerator, it's quadratic. Don't know. I'd have to examine that a little bit more closely to see if it has any places where it's 0. And looking at the graph, apparently it's hard to say. It looks like maybe I can't tell if this is going above the x-axis here or not. So I'd need to look at that a little bit more closely. Maybe it crosses a couple times here. Let's see. The original concave down. It changes concavity. So yes, it must be crossing the x-axis a couple of times. So it looks like it crosses twice in here. Somewhere where this changes from concave down to concave up. And then maybe back to concave down again. I can't really tell what it looks like there. It may stay concave up. It's hard to tell. Looks kind of concave up right here. Oh, and it definitely crosses once right there. Yes. So that's a place where we have an inflection point here where it changes from concave up to concave down. So it actually is going to cross twice. So the second derivative is 0 twice whenever this numerator is 0. You can use a quadratic formula to find those exactly. And 1 is about here, about 1 point something, 1.1 something maybe. And that's when we're going to have an inflection point in the original function where it changes from concave up to concave down. And also somewhere, I would guess somewhere around 5-ish, somewhere in this vicinity, looks like it's crossing again, and we have a minimum on the derivative and an inflection point on the original function where it changes from concave down to concave up. Stays concave up from there on out. We have a maximum at the derivative right here where the inflection point's in the original function and a 0 on the second derivative. Second derivative is positive x over here, and so we see the function is all concave up over here in this last piece on the far left, and the derivative is positive over there, so the function is increasing. This piece in the middle here, the derivative is negative down here, and so we see the original function is decreasing between the two asymptotes here. And over here to the right of this last asymptote, the derivative comes down and crosses the axis right there at 2 point something, and so that's where we have a maximum here. So a local maximum. So it's increasing concave down to max, then it starts decreasing, still concave down. Where the second derivative crosses the axis, it switches to concave up and continues to decrease on out for forever to the right. And let's see, if we look at the original function, as x goes to infinity, this whole thing is going to go to negative infinity. This fraction is going to go towards 0. The whole thing, the absolute value of the square root is going to go towards 0, but logarithm as x goes towards 0, the logarithm of something as the something goes to 0 goes to negative infinity. So we should see this graph going out towards negative infinity. No horizontal asymptote there, and the same thing's true on the other end. Goes down forever. The tangent line. Okay, let's go back to the original function and put in 1 here. Let's see what we get. 4 times 1 is 4, minus 7 is negative 3. 1 cubed is 1. Negative 3 divided by 1 is negative 3. Absolute value negative 3 is 3. So we have the log of the square root of 3, or 3 to 1/2 here, so it would be 1/2 log of 3, natural log of 3. So there's I'll write it that way. That's, so you could have written it this way, it's the same thing. That will be the y value of the function and the y value of the tangent line, both, when x is 1. And we go to the derivative function, we pull that down right here, put in 1 for x. Here are the details right here. Here, here, and here, put in 1. Let's see, 4 times 1 is 4, minus 7 is negative 3, times 1 times 2 is negative 6. Got a negative out front. 8 minus 21 is negative 13. 3 negatives make us a negative, and that's 13/6. That's our slope. So negative 13/6 times x minus 1 plus 1/2 the natural log of 3. That's the equation of the tangent line, which you see here, and it should cross the touch the graph of the original function right there when x is 1, y is 1/2 natural log of 3, and it follows closely the curve right here close by, and so we see that is the appropriate tangent line. Okay, one more in this set of problems here. Here we have a variable base and a variable power. Don't worry about the second derivative on this one, but see if you can come up with the first derivative and the tangent line when x equals 1. See if you can do that before you watch the next video.